Good morning, all. In the last class, we have discussed about uh, various reactions to different parts of the blast furnace, starting from stack region, then followed by belly, wash, clear part, and hearth part of the blast furnace. So we have seen what are the various reactions which takes place at every part of the blast furnace, which are some are reactions of uh, gas solid reactions, some are solid solid reactions, some are uh, gas metal reactions, some are slag metal reactions. So like that, we have seen various reactions which was happened at different parts of the blast furnace, and whatever it may be the interactions between different phases, but the ultimate adjustment of the composition of liquid products which are forming in the blast furnace will be done at the hearth part of the blast furnace, where both the slag as well as the metal will come and settle down, and where the final uh, adjustments in the composition of hot metal as well as slag will take place because of the mass transfer which takes place between the slag and the metal. And once these liquid products are formed in the blast furnace, as we discussed, that slag is having a low density compared to that of the hot metal. So the slag will float on the surface of the hot metal, and that is how the arrangement will be in the blast furnace. So these products have to be tapped at regular intervals of time from the blast furnace. So for that, we need to um, drill the tap hole. The tap hole is drilled with a mud gun, and then liquid products are tapped from the blast furnace. So you can see the densities of slag as well as the hot metal. Density of the hot metal will be of around 7.2, and the slag will be of around 2.4. So this great difference between the densities of the two liquids leads to very good separation of hot metal as well as slag in the hot part of the blast furnace. Not only that, even in the runner also. The runner, which is rough, which is arranged in front of the pier, is basically lined with sand as well as coke beads, and water-based clay is also used. And a good runner should consisting of a very good resistance to the erosion from liquid products with the flowing through, and also it should have resistance to high temperature as well as the shock resistance. So cast house operations. So basically the tapping and all, whatever it happens, the blast furnace, that is nothing but the cast house area. And the objectives of the cast house is to remove the liquid product, that is the hot metal as well as slag from the furnace at regular intervals of time, so that uh, so that the level of the liquid products in the hearth of the blast furnace will not be get affected. And if the level is getting increased, then again that will show an impact in uh, the raceway of the blast furnace. And also another objective is to separate the hot metal as well as slag from each other by giving a certain deviation, so that the slag will collect into the slag pot, and the hot metal will collect into either in the ladle or in the torpedo. So in this particular picture, you can see that this is the tap hole from which the liquid products are coming out, and this is the runner. This is the runner area, and there is a skimmer which actually separates the slag as well as the hot metal. And here you have a slag runner is also there, which deviates the slag, and that will collect into the slag pot. And the hot metal, whatever it is traveling in the forward direction, will collect either in the torpedo ladles. This is a torpedo ladle. Or if it is a mini blast furnace, then they use small transfer ladles to collect this hot metal. So you can see in this particular picture that the hot metal from the blast furnace is tapped, and it is traveled through the runner, and it is finally getting collected in the torpedo ladle. And this torpedo ladle is also a refractory lined vessel, and it can collect a huge quantity of metal. And there is a small provision for the collecting of this hot metal. This small inlet is given just to avoid the heat losses during its transfer from blast furnace department to the steel melting shop. So the number of tap holes for any blast furnace purely depends upon its capacity, the capacity of the blast furnace, and it may range from 2 tap holes to 4 tap holes. And these tap holes are openings in the blast furnace with special refractory construction built in the hearth side walls. And these tap holes are opened by, as I told, we use the drill bit, and we open the tap hole during the tapping condition. Once tapping is done, again these tap holes are closed with a refractory clay, so that the process will be continued. And at high temperatures, this clay will get hardened, and it will certainly seal this hole. And during this filling condition, a certain amount of tap hole clay can also enter into the inside the blast furnace, and that extra part of tap hole clay which is entered into the blast furnace is called as a mushroom, and that will actually protect the original refractory consumption. So whenever there is a tapping is there, because of their high velocities, there is a possibility of erosion of the tap hole area will take place, and that eroded part will be compensated by this tap hole clay. So you can see in this particular picture that this is the mushroom which is extended into the blast furnace area. And initially, this is the condition. This is the refractory lining what we have, and as the more number of tappings are happening, there is a possibility that there is an erosion of this refractory lining may takes place, and again to rebuild that particular eroded area, this tap hole clay will help, and it will form a newly lined refractory system. So you can see this brown part is nothing but the tap hole clay, which is formed as a newly lined refractory system here. And this extended part, whatever it is there, this is called as a mushroom. You can also see the same thing here. This is called mushroom. This is the clay gun, which is injecting the tap hole clay. And this mushroom part basically will protect the tap hole from the wear. And you can also see the different kinds of tap hole clays, different um, companies and suppliers. These are the some of the chemical names of the tap hole clays. EcoTap 232M and EcoTap 531 ms, EcoTap 260 ms. These are the some of the tap hole clays. And also the length of the tap hole, how much we need to uh, fill the tap hole. That is again, it depends upon the size of the blast furnace, and the depth of the drilling is vary from a plant, from furnace to furnace, and that also it is mentioned in this particular table. That if a blast furnace, the size of the blast furnace is less than 1,000 meter cube, then the length of the tap hole should be of approximately 1.5 to 1.8 meter. And if the size is between 1,000 to 2,000, then it is a 1.5, 1.8 to 2.5. If it is 2,000 to 4,000 meter cube, then it will be the length of the tap hole may be approximately 2.5 to 3.2. And if it is greater than 4,000 meter cube, then approximately it will be 3 to 3.5. Okay, so this is how uh, the length of the tap hole varies from furnace to furnace based upon its dimension. And this is the tap hole drilling machine. And you have this is the drill bit which is arranged to this particular lancing system at the front, and the and this will basically drill the tap hole during the tapping condition. And also you can see some of the other pictures, like this is the slag pot. We have already seen the torpedo ladles where the hot metal is collected in this thing. Similarly, the other liquid product, that is slag, which is formed, that will be collected into the into the slag pots. So slag pot looks like this. Okay. Apart from this, there is also another facility which will be always available in integrated steel plants, that is the pig casting machine. So whenever there is um, non not requirement of hot metal in the steel making shop, or any extra excess amount of hot metal is provide is uh, generated, and these hot metal cannot be preserved for longer time in either torpedo ladles or transfer ladles. So excess amount of any hot metal which is present, that hot metal is diverted towards the pig casting area, where you have a series of molds will be there, and the through the launder, the hot metal is poured into these molds, so that the liquid gets solidified inside these molds, and it forms pig. And these ingots or pigs kind of thing, that will be preserved in a solid form in the yard, and whenever it is necessary, again you can reuse this um, solid ingots into the steel melting in the steel melting area, and they can produce the steel. So here in the pig casting machine, initially there will be a coating will be done to these molds, so that the solidified product can be easily detached from the molds. And at the initial stages, this liquid product will expose to the air cooling, and followed by there will be a water cooling will be there by water jets. And at this, when it comes to the end of this pig casting machine, the pigs will be get detached. If it is not detached, then also there will be hammer kind of a system will be there here, which gives a vibration by hitting. And by that way the mold, the sorry, the ingots or peaks can be detached from the mold. And in the reverse direction, here you can see there will be mold coating will be done, so that a non-sticky kind of a behavior can be achieved. So in this way, the excess amount of liquid hot metal, whatever it is generated in the blast furnace area, that can be converted into solid form, and you can preserve that for further usage. This is nothing but the torpedo ladle, what I have discussed. And then the hot metal that is tapped is collected in these torpedo ladles. Um, which is having a capacity ranging from around 150 to 300 tons. And these ladles are called torpedoes because they are shaped like a torpedo, uh, having a conical ends and a cylindrical barrel shaped central body. And these ladles have a central opening at the top through which the hot metal flows into the ladle. And as it is filled near the blast furnace, so once the torpedo ladle reaches to the steel melting shop, the hot metal is poured out through this opening, as the entire ladle is slowly rotated using an electromagnetic device. And here, once this torpedo ladle moves to the steel melting shop, and this can be rotated, and just beside this there will be another transfer ladle will be there. Hot metal will get collected into the transfer ladles, and to the canes that will be lifted. There will be certain amount of heat losses will be there during its traveling from one area to other department. And also there are certain amount of losses of heat will also takes place because of the refractory walls through the conduction mode of heat transfer. However, at the melt shop, when hot metal is poured from these torpedo ladles into the transfer ladles, and subsequent hot metal charging into the basic oxygen furnaces, and considerable heat loss takes place on account of radiations. So for this reason, the metal as well as the slag tend to get solidify around the mouth of the torpedo ladles. Therefore, it becomes necessary to remove the solidified slag or solidified hot metal from the mouth of the torpedoes periodically. In general, around 200-ton torpedo can easily transfer 3 lakh tons of hot metal before its relining. So that is the campaign life of a torpedo ladle. While 3,200-ton ladle can easily get transport around 5 lakh tons of hot metal. So these torpedo ladles are basically used when you have huge quantity of hot metal should be transported from blast furnace department to the SMS area. Otherwise, if you are running with the mini blast furnaces, then you can use uh, transfer ladles, 100-ton capacity or something like that. And coming to the slag, um, along with the hot metal, we are also tapping the slag from the blast furnace. So, and in the runner part of the blast furnace, this is um, getting deviated, and the slag, as its density is less, it floats on surface of the liquid metal, and this deviated slag get collected into the slag pot. And for blast furnaces to have a good blast furnace slags, to have good fluidity, we maintain the basicity of this slag is around 1.2 to 1.4, and the alumina content should not be exceeded more than 18%. In general, in Indian blast furnaces, we have Al2O3 content in the slag ranging from 18 to 20%, and in rainy seasons, maybe it will extend to 2 more percent. Actually, a lot of problems will be arised when alumina content in the blast furnace slag is um, if it is either less or if it is exceeded 20%. Alumina slags generate a huge viscosity, and because of which the fluidity of the slag will be very, very poor inside the blast furnace, and that will certainly damage the permeability of the bed inside the blast furnace. And to overcome this, we need to again add a huge quantity of fluxes to make these slags highly fluid. So the flux consumption also can be increased, and because of which ultimately there will be slag volume which is generated inside the blast furnace will also get increased, and that will certainly hamper the productivity of the blast furnace. Not only that, high alumina slags, because of high viscosities, they have very poor desulfurization rate also. So to overcome this, we have to add more amount of fluxes, and also make it fluidity. Then you have to add more amount of fuel also. The fuel consumption also will be increased, and the flux consumption also get increased, and these all together will give great increase in the volume of the slag, and productivity of the blast furnace will be decreased. And if you see the applications of this slag, especially the blast furnace slag, typical composition of Indian blast furnace slag, if you see, it will be of ranging having CaO ranging from 30 to 36, and SiO2 around 28 to 32, and Al2O3 maybe around 18 to 22, and MgO 9 to 12%. And these slag, whatever it is generated, can be cooled down, and depends upon the kind of the application. We give different cooling techniques, and nowadays they are doing slag granulation and all, and also they are doing cleansing of these slags. Also, automation also they are doing, where the this slag is converted into gas balls in the blast furnace area. Air-cooled blast furnace slags, if you see, when these slags are slowly cooled down in a slag pit under normal ambient atmosphere, crystalline phase will form, and after crushing this, it is used as a filler between the rail slippers or as glass sand, etc. And Granulated slag, the most popular use of blast furnace slag is the GGBS, ground granulated blast furnace slag is used in cement industry. For this purpose, it is granulated by quenching it under a forced water jet, which does not allow crystallization, and slag remains completely amorphous form, glassy form, and such a granulated slag has a very cementitious properties suitable for the cement making. So majority of the blast furnace slag goes for the cement manufacturing process. So, and foamy slag, when slag is quenched in a controlled manner, that is the cooling rate not too high or not too low. The quenching is done through water or air mixture, allowing flexibility in cooling rate, and certainly the slag foam with a cellular slag structure, which can be used for making the floor tiles or bricks or building blocks and all. And also this slag is used for the production of wave breakers. You can see in this particular picture that these wave breakers are located around the nearby the seashores, which does not allow the high waves to um, generate. And also you can see water cooled slags have some porous nature, result in the foaming and all, and these are also is used for as a metals and all. And even in the construction area also, these blast furnace slags are also used uh, in the place of pebbles. They use this PF slag. So in the next class, we will see the blast furnace blasting systems. So overall, if you see, there are three different products which comes out from the blast furnace. Two are the liquid products, and one is the gaseous product which comes out from the blast furnace. From the bottom of the blast furnace, we get hot metal as well as slag. Hot metal is further subjected for the refining operations, and it is depends upon the composition of the hot metal. Sometimes it can be subjected for some external sulfurization or desulfurization and all. Otherwise, if the composition is okay, then it is directly sent for the further refining operations, which is done in the steel making area. And the slag, whatever it is generated, that is used for various purposes. And apart from this, these are the two liquid products which comes out from the blast furnace at the bottom. And apart from this, there is another one, that is the gaseous product, that is the off gases, the BF off gases, which goes out from the top of the blast furnace. So that is all. That is having very high calorific values. So that is basically also um reused before subjecting some uh, gas screening stages, and that clean gas is further used for preheating of stoves and all. So in the next class, we will discuss about utilization of the BF off gas.